Let R be the region bounded by y equals 4.5 minus x squared, the x-axis and the y-axis. So we have they've given us a nice little picture right there. There we go. So there's the curve. So this is the line y equals, the curve. 4.5 minus x squared is part of a parabola turned down, like negative x squared, you know that function. Okay. And then the x-axis, here is the x-axis. And the y-axis, there's the y-axis. So that region, we're going to rotate now. We're going to find the solid obtained by rotating this region R about the line y equals negative 3.25. So here it is on this image. I put it into the 3D Desmos thing, or this is actually a GeoGebra. Anyway, it's down 3.25. So this is negative 3.25 right there. That's the line y equals negative 3.25. So we're rotating about that line. What's going to happen? Well, this little, region R we have, as it rotates, it's going to go down there, isn't it? And there is the three-dimensional image of what will happen when we rotate it about that line. So um, let's find the volume of that shape. How are we going to find the volume of that shape? Well, these are washers, clearly. You can just look at that three-dimensional image. You got holes in the middle. So these are washers. And you know how to find the volume of a washer. Volume of each washer is pi capital R squared minus pi little r squared. Take the whole circle and subtract the whole out of the inside times the thickness. Oops. So what is thickness? Is going to be dx or dy. We can see it's dx just by looking right here. It's dx. And that makes sense, right? You can see as we stack these things up, the thickness of each one is dx. This is the x-axis, dx. You can see it here too, the d on the 3D axis. This is the x-axis, this is the y. So it's dx. They're stacking along the x-axis. Okay, so now we got the whole work is always to find the big radius and the little radius. Okay, so you can tell from this little diagram, this is actually very helpful right here. Um, that right there. It's the big radius, right? The radius from the middle to the outer, the capital R is the outer radius, right? So we can see it right here as well, all the way to the outer edge, the out in the 3D picture, right? It's from the middle to the outer edge of the washer. What's that going to be? Well, this is the curve again, y equals 4.5 minus x squared. But careful, that's just the y value. That just means from, oh, here, that's going to be confusing, huh? That just means from here to there is that y value. Let me write that, right? That is y equals 4.5 minus x squared, isn't it? Because that's what a y value means. Think about when you graph, right? You start at the origin, you go over x, you go up y from the origin, from the axis, right? So from the axis up to the graph, that's called the y value, which is 4.5 minus x squared. The outer radius is more than that. It's from here all the way. So it's going to be the y plus the 3.25, isn't it? Because we know from here to here is a distance of 3.2. Now you might say, but it's negative. Whatever, it's distance. Right now we're just saying how long is it. If I say, how long is that trip? Nobody says negative 200 miles because it's down south, right? Or nobody measures a yardstick and says it's a yard, but it's negative because I went to the left. No, no, distance is just distance. We don't call it negative. I mean, I know that line is down there, but we're saying how far from here to here? 3.25. How far from here to here? Y. So what is capital R altogether? Capital R altogether will be Y plus 3.25, won't it? And what is Y? That it'll be 4.5 minus x squared plus 3.25. That'll be the capital R. That's the outer radius from the line of rotation all the way to the outer radius of the washer. So there we go for that. So this is going to be I, and then the outer radius we can see is 4.5 minus x squared plus 3.25 squared. And that's what they have right there, see? Minus, now what's the inner radius? I times zero. Well, the inner radius, that's just that 3.25, right? The inner radius is just from here up. You can see it in the three-dimensional. Right there to there, that's your little r. That's your inner radius for the washers. They're all the same inner radius. They just have different outer radii, to use the official word there. So this will be 3.5 squared. That's the inner radius, right? And then we just need to throw a dx on the back of that. Now, where's our integral going? From where to where? Well, it's going to go along the x-axis from here to here. Now, where's that hit? A little bit past 2. You can see they got the number 2.12, did it out. How did they find that? Right? Because that's how we're stacking them up, right? We're going along the x-axis here. And we're going from here, x equals 0, to here. So that's x equals what? How do we find that? Whoops. How do we find that value on the x-axis? Well, it's a point on this graph, and it's a point that has a height of 0. So take that little equation and plug in y0, right? And you'll find the x value. Is that making sense? So we're just going to plug in to this because this is where this curve hits a height of 0. So take the equation for that curve, plug in y height of 0, find the x. So how do I find the x? We'll jump this guy to the other side. I'll bring it over here. It becomes positive x squared is 4.5. And then you know how to do that. Square root it, square root it. X is square root of 4.5. So and that is the 2.12 blah, blah, blah number. 2.1213. So that is where our integral stops. And so there we go. There's the integral to find the volume of that shape.